So today we're going to do section 3.2. It will be a shorter lecture, luckily. It's all about the graphs of functions. So yesterday we talked about function notation and what a function looks like, meaning one input and one output. What we're going to do today is bring back into the idea of what a graph of a function would look like. So I did send out notes yesterday afternoon. I don't know whether you caught that email or not, but there is a PDF file that has all these pictures on it. So that's kind of helpful. So what we're going to do is I have one on the board already, but before we take a look at that picture or that graph, I want to talk about how we know if a graph is a function. So how to tell if a graph represents a function. You know, what we're talking about yesterday, we looked at equations and how to determine if an equation is a function. Here we're looking at a picture. So not the equation of a graph, but the actual graph itself. So the key here is the one input, one output. So that's kind of our definition of a function. So what that really means is that each x value has only one y value. Those are all saying the same thing, just with different wording. Okay, well, if each x has only one y, then that means that any vertical line would touch the graph in only one spot all along its length. So in other words, if I use the edge of my paper as a vertical line and take a look at this picture that's on the board, and I'm sorry, I really thought that red would show up better than it does on the computer. But if I take my vertical line as my edge of my paper and run it all along the length of this, we're going to see that it only touches the graph one point anywhere along. So if I stop it right here, there's one x, one y. If I stop it over here, there's a single x to a single y. And this is called the vertical line test. So we're going to use the vertical line test. So it simply says that if it intersects, if the graph touches a vertical line, meaning up and down, more than once for any value of x, it's not a function. It's really hard to write out. So again, if the graph touches that vertical line more than once, anywhere along the length, for any x value, it's not a function. So the one we have on the board is a function because it touches the vertical line one time in every spot. Okay, have you heard of the vertical line test before?
Yes.
Usually something that's in the background for most people. Just to reiterate, I found my blue ruler that came with the board, so that's a little easier to see. You'll see that it's only touching at one spot all along the length. So definitely a vertical line. Okay, so what we want to do is once we know it's a function, and we'll do some that are not functions here in a bit, but we'll start off with this one. We need to be able to pull information from a graph. So our first example is going to use this picture. We have a point over here at 4, -2. We have another point at -2, 1. There's a point at 0, 0. Another point at 2, -2. Another point at 4, 0. A 5, 3, and a 6, 0. It is a continuous graph. Continuous simply means that you can trace along the whole length of it without having to lift off your pencil to trace it. So it's continuous. That means all the integer values are there. All the decimals and the fractions are also there. So our first question is going to be, they want us to find f of 0. So we want to find f of 0. So if you remember right from yesterday, this is our x value. So this is the input. So they're telling me to go to my picture and look where x is equal to 0. Well, x is equal to 0 right here at the origin. So they're asking me for the output or the Y value. It corresponds to that. So the output, that's my Y value. The output at that point is 0. So again, this is telling me what X value to go to. This is telling me what they're looking for is the Y value. So F of 0 is 0. So yesterday we had an equation to plug it into. Today we have a function or a graph to pull it off of. Okay, that same question also asks us to find F of 6. So what is F of 6? So this time your input value where X is 6, what's the corresponding Y value for an X value of 6? Anybody?
0.
Yep, beautiful. So F of 6 is also 0. And you can see that this is giving us coordinates of points, the 0.00 and the 0.60. Let's do another one. So part B, moving, if you printed out the handout across the page, because that's where B is, let's find F of 2. What's F of 2?
-2.
Very great. So F of 2 is right here. The X value is +2. The Y value is a -2. Yay. And then it also asks for F of -2. So what's F of -2?
One.
So we're going to go over to an X value of -2. We go up to the graph. We see the corresponding Y value is +1. Nice. So this is why tonight's homework is a lot quicker, because this stuff, if you see it, is fairly quick. Okay, part C on that one is asking me whether or not is F of 3 positive or negative. So is F of 3 positive or negative? So I'm going to come over to my picture. I'm going to look for where X is equal to 3, because again, this is the X value. So X equal to 3 is right here, so it's a point right here. The corresponding Y value is negative. So they're asking me what is the Y value, and in this case, the Y value is negative. The X was a +3. The graph shows me that the Y value is a negative. Comments about that? Does that make sense? Okay, part D on that one says is F of -1 positive or negative? So is F of -1 positive or negative? So we'll do the same thing. We'll come to our picture. We'll go over to where X is equal to -1, because that's the input value. The graph is up here, and it's above the X-axis, so the corresponding Y value is positive. So to answer that one, we know the answer is positive. And again, you're going to have to stop me if you don't understand. Otherwise, we'll just move on. Okay, part E is asking for what numbers of X. So for what X is F of X equal to 0? So this one's kind of the reverse question of what we were doing before. This time you're being given the Y value is 0. We want to know what X's correspond to Y values of 0. Okay, well, we're going to look for Y values of 0. That means I'm on top of the X-axis. So there are actually 3 of them. So the first one would be at the origin. The second one would be at 4. And the third one is over here at 6. So for each of these X coordinates, the corresponding Y value is also 0. Math is its own language. Part F wants to know for what X is F of X less than 0. So this is a little bit harder question. So again, what they're asking this time is the Y value is 0, but not just 0, we need to be smaller than 0. What this is really asking me is where is the graph below the X-axis? Because anytime the graph is below the X-axis down here, we know the Y values are less than 0. It has negative Y values. So this is simply asking me where the graph is below the X-axis. And for us, we can see that this little cup down here is where the graph is below the X-axis. So it's below the X-axis, starting at an X value of 0 ending at an x value of 4, and I'm going to put that in parentheses. So this is actually the interval from 0 to 4. So it's a range of numbers starting at 0, ending at 4. And I used parentheses on my interval because the inequality is just a less than. If it had been a less than or equal to, I would have to use a bracket. Does this part make sense? Does F make sense? Because that's the hard one if you ask me.
Yes.
Okay. Part G is asking the domain of this function. So they want to know what the domain is. Well, we know from our work yesterday that the domain is the set of input values. So that's the set of x values. So on a picture, the domain is basically the x values from left to right. This is the x values from left to right. So going from the left side to the right side, what x values are being used? Well, our picture starts on the left side at an x value of 4. It continues all the way out to the right side, and it ends at an x value of 6. So we know we have an interval going from 4 to 6. Now, because we have closed circles on both ends, we know we're going to use brackets. So our domain is from 4 to 6.
Is it a -4, 6?
Oh, yeah. Huh. That's actually wrong with my picture. -4, that's a +2. Yeah, it's a -4. Thank you. I didn't catch that when I copied it up. Okay, what about the range? That's part H. So the range is the y values that are being used on the graph, and that's from the bottom to the top. So let's, just like you read an old-time thermometer, it's from the bottom to the top. That's to get it in numerical order. So the bottom of our graph is over here at -2. The top of our graph, the highest y value we see is this value of 3. And because they're closed dots or closed circles, we know we're going to use brackets again. Okay, now notice that where we're starting and stopping in the x values and where we're starting and stopping in the y values don't correspond to the same points. So again, the domain is left to right, just like you read a book, and the range is the bottom to the top, and that's to get everything in numerical order. So, comments about that? Part I is asking for the x-intercepts. So the x-intercepts. So where is our graph touching or crossing the x-axis? Well, the first one's over here at 0, 0. The next one is at 4, 0. And the last one is at 6, 0. So the x-intercepts we've already talked about. That's easy to pick off. Part J is asking for the y-intercept. So where does the graph touch or cross the y-axis? The origin again. So this points out something kind of important. You can have numerous x-intercepts on a function, but you can only have one y-intercept, because if it were to wrap around and cross the y-axis again, it would fail the vertical line test and not be a function. So a graph can only have one y-intercept, but lots of x-intercepts. There's no limit on that. Question K, you'll have one of this like this on the homework. It's got like 12 parts to it again, but it's much easier than last night's. So it's the first problem, in fact. Okay, part K asks, how often does the line y equal to 1 intersect the graph? Okay, so we did not cover lines because we assumed that you did that in a preceding course. So just as a reminder, the line y equal to 1 is a horizontal line at 1. So I'm going to use colors here. So it's a horizontal line at 1. So if I come in and draw that horizontal line in, how many times is my picture intersecting that? And this is why I passed out the notes, because I was really worried about the drawing on the board. So it's really only intersecting it here, here, and here. So it's intersecting that 3 times. So the answer to the question would be 3. L is kind of the opposite question. We want to know how often. Does the line X equal to 1 intersect the graph? Okay, well, X equal to 1 is a vertical line. At 1. And the minute I talk about a vertical line, we know it can only intersect at 1 time and still be a function. So if, sure enough, if we draw a vertical line at X equal to 1, we'll see that it only does it 1 time. It crosses it 1 time. So it's going to intersect 1 time. Okay, question about the horizontal and the vertical line and how many times it's touching our picture?
Makes sense.
Yay! Okay, 2 more questions to this part, or this problem, we can move on. Part M, yes, that would be M. For what values of X? So for what X? Does f of X equal 3? So again, they're giving me the Y value and asking me for the corresponding X value. So for what value of X does f of X equal 3? Well, looking at my picture up here, I'm looking for a Y value of 3. The only place we see a Y value of 3 is up here at this peak or this top. So the answer is that X equals 5. And that would give me the 0.5, comma 3. So again, what we're really saying is that f of 5 is equal to 3. In part N, same kind of question for what value of X. So for what X does f of X equal -2? So f of X equal -2. So again, that's the Y value they're giving me. We need to find the corresponding X value. So for us, our Y value of -2 occurs over here. The corresponding X value is a +2. So X is equal to +2. Okay. So there was a graph of a function. They asked me all kinds of questions, a lot of different types of questions. Anybody have any problem with any of them?
I'm okay.
Yay. Good. So then we'll move on. I can erase my beginning graph. Okay, our next example, the directions on all of them are going to ask us the same thing. So what it's asking says for each of the following graphs, this is example 2, I want to first determine if it's a function. So determine if it's a function. So is it a function? Is it a function? If it is a function, then find the following. So if it is a function, we want to find the domain and range. We also want to find the intercepts. And then finally, we're going to talk about symmetry. So tying in stuff we did before the exam. So then there are quite a few of them. There's 6 of them to look at. So 2A looks like this. This is accurate. 2, 2, 2, 2. And it looks like that. So they gave me a graph. They want to know whether or not, first of all, if it is a function. If it is a function, then find the information. So is that one a function or not?
No.
Why not?
Fails the vertical line test.
So no, and that's exactly it. So it fails the VLT for vertical line test. That's exactly it. So because it's not a function, I don't have to do the rest of it according to the book. So I'm done with that problem. That was the quickest problem ever. Part B looks something like this. So we have a point here. This is at -1, 2. I have another point over here at 1, 2. And it does this. That's -3 and that's +3. Okay. So that's part B. That's what the graph looks like. Okay, so is that one a function? Will it pass our vertical line test? So if I run my vertical line all along its length, it only intersects it in one spot all along the length. Whereas the circle up there would intersect it in multiple spots. So this one's a function. So I'll say function. And now we have to go find the information. So the MyLab math homework gives you spots to put everything into. So here we have to be a little bit more organized. I'm going to use a capital D for domain. It's just quicker than writing out the word. So what is my domain? So from left to right, what X values are being used? Does anybody have a guess?
These are all real numbers.
It is, and the reason it is because on the end of our picture for the first time we see arrows, and each of those arrows is telling me that as it goes out in terms of X's, it's going down in terms of Y's. So it goes on in terms of -infinity to infinity. So you can write the domain from -infinity to infinity, or you can use the symbol we talked about yesterday for all real numbers. I'm fairly sure that MyLab Math is going to use interval notation. You guys are going to do the homework and let me know. I don't think it has a spot where you can type in all real numbers, but I could be wrong. I haven't used it. It's new to me. Okay, what about the range? The range is the bottom of the graph to the top of the graph. So these arrows that are heading down tells me that the graph is starting down there at -infinity. Where is it stopping?
2.
+2
Yep, +2. And what do you want on the end of that? A parenthesis or a bracket?
bracket.
Yeah, and that's because it's part of the graph. It's included. Great. Okay, the intercepts are pretty easy to pull off. The x-intercepts are going to be over here at -3 and +3. So -3, 0, and +3, 0. What about the y-intercept? Where are we crossing the y-axis at?
0.
In terms of
Or
the
2.
x, yeah, 2. Beautiful. So there's our intercepts. And then the other piece of information they want to know is, what about any symmetry? So can I fold this across anything and have it fold onto itself?
The y, it's y symmetrical.
Yeah. It has symmetry to the y-axis. That's exactly, because I can pick the left side up and fold it onto the right side. It does not fold across the x-axis and definitely does not double fold because there's nothing on the bottom side of it for us to fold onto. So beautiful. So yeah, I think you have like 4 of these total to do. 1, 2, 3. No, only 3 it looks like. Part C. I've written all of the board. Is a picture that looks like this. And we haven't seen anything that looks like this before. So I have an open circle over here at 3, 2. And it goes like that. So the graph looks something like that. Okay, is that a function? Yes or no?
Yes.
Yes. So this is actually kind of sneaky. So what's being implied here is we do this because it looks like it goes vertical. Then it wouldn't be a function. But it's actually got something called an asymptote sitting over here, which we will do eventually. It takes us a while to get there, but we'll do them. And as we get closer and closer and closer to the axis, it is getting smaller and smaller in terms of x. It's never going to cross the y-axis, but it gets closer and closer and closer to it. So it's a function. It's an implied function. What's our domain?
-infinity to 2.
Well, so -infinity implies that it's going off on this side. And is it ever going to the
no.
left side?
No.
So we're going to use 0, and then we're going to stop it at 3. On the 0, we're going to use a parenthesis because we're going to assume, and again, you have to assume things at this point about this type of picture, is that it's going to get closer and closer and closer to it, but it's never actually going to touch 0. So we'll put a parenthesis there. And it also doesn't touch the 3 because that's an open circle. So we'll do a parenthesis on the 3 also. So our domain goes from 0 to 3 for this problem. And what about the range? Here's where your negative infinity comes in, right? Because the bottom of the graph is down there at negative infinity. Where's the top of the graph?
2.
2. So its x-intercept is sitting there at 1. So 1, 0. And the y-intercept, it doesn't cross the y-axis. The domain is saying you're never going to have an x value, or I'm sorry, a y value of 0 or an x value of 0. So we're going to come in and say there's no y-intercept because you'll never have an x of 0. No. What about symmetry? Does it fold across anything? Does not. This open circle wouldn't fold down because there's no open circle down here to fold onto. I can't fold left to right because there's nothing on the left. So it has no symmetry whatsoever. Okay, is everybody okay with those? There are 3 more examples on the file, but if you're okay with it, we'll skip them and move on. Are we good?
Yeah, I'm okay.
Okay, then I'm moving on. I don't know if you heard the dog just come in. Forgot to close the door. He was just outside barking. He's kind of noisy. Example 3 says, okay, this time I want to say f of x is equal to 2x squared minus x minus 1. So that is a quadratic function because the highest exponent we see is a 2. So that's 2x squared minus x minus 1. Now what they're going to do with these guys is try and relate the equation to the graph without actually graphing it. So part A wants to know, is the point -1, 2 on the graph of that function? So I don't have a picture, but is the point -1, 2 on the graph? So what are they really asking me to do? You got a guess?
Substitute.
Yep.
The-
So what we're going to do is we're going to come in and plug in -1 for the x, because that's the x value of the point. So let's plug that in carefully. So I have 2 times the -1, which I have to square, minus a -1, -1. Now be careful, order of operations is so crucial here. You must do any exponents before you do any multiplication. So we're going to take that -1 and square it first, which makes it a +1. So then I have 2 times 1, which is 2, plus 1 minus 1, and sure enough, I'm going to get 2, which is what they said the output would be. So because that 2 matches the y value of the point, yes. We'll say yes, it's on the graph. So, it's exactly it. All we had to do was plug in the -1, see if we get their corresponding y value, and we're good to go. Okay, but again, order of operations. Part B says if x equals -2, what's f of x? F of x. And then it goes on to ask what point or points are on the graph. So we did this yesterday. They gave us a value for x. We had to plug it in. We can do that. So let's go find f of -2. So that would be 2 times -2 squared minus a -2 minus 1. So again, I'm using that same function, 2x squared minus x minus 1, and replacing it with a -2. So that -2 squared is going to be a +4. The double negative makes that a +2. 2 times 4 is 8, plus 2 minus the 1. And that's going to give me 9. So when I input a -2, I'm going to output a 9. And then that tells me that the point -2, 9 is on the graph. What they're doing here more than anything else is making sure you understand which value is the input, which value is the output, and how to write that as a point. Comments? Part C, a little bit different. Here what they're going to say is if f of x equals a -1, what is x? And then again, they ask for what points are on the graph. So in part B, they gave me the x value. For part C here, what are they giving me?
The Y.
The y value. So we're going to set -1 equal to our function, 2x squared minus x minus 1. And now we need to solve for x. Okay, so to solve for x, we're going to move the 1 across. Because this is a quadratic, because I'm seeing an x squared, I know I have to set it equal to 0. 2x squared minus x. We'll factor that. I'm going to pull an x out. That'll leave me with 2x minus 1 in parentheses. So I factored out an x. That leaves me with 2x minus 1. And then we'll set each factor to 0. So x equals 0. 2x minus 1 equals 0. So x is equal to 1/2. So to answer the question, we get 2 values, which is okay. Each of those inputs corresponds to a single output. It's okay if a y value has 2 inputs that it comes from. So we have 0 is one value, 1/2 is another value. But as far as the points go, you'd have the point 0, -1. 0 that we solved for, the -1 was the corresponding y value they gave us. The other point would be 1/2, comma, -1. So they both have -1 as their y. So they gave me an x, I had to find the y. They gave me a y, I had to find the x. Part D on that question asked me to find the domain. So what's the domain of this function? So this ties back to yesterday's lecture. I take a look at my function and I notice it has no even root. It also has no x in the denominator. Those are the only 2 restrictions we have to worry about right now. So because it's not an even root and because x is not in the denominator, I know that my, whoops, sorry, got to plug in the computer. I know that the domain is all real numbers. So, and again, you can write that as -∞ to infinity, or you can write it as all real numbers. So, -∞ to infinity or all real numbers. They're not going to ask us about the range yet, because to get the range at this point, we need a picture. All they can do is ask me about the domain, and that ties to yesterday. Part E asks for the x-intercepts. So to find the x-intercepts, we know we have to set y to 0. So we're going to set the function equal to 0. So set f of x equal to 0. So 2x squared minus x minus 1 equals 0. I noticed that some of you were definitely struggling on factoring when I was going over the exam work. So you might want to go back to the review chapter and look it over when you get a chance. This factors into 2x with a 1 and x with a 1. That's going to be a negative. That one's a plus. And again, I know it works because factors of 2 that subtract a 1 are 2 and 1. So we'll get x equal to a -1/2 and x equals 1. So that would be -1/2, 0, and 1, 0 is our x-intercepts. So again, we already know how to do that. We talked about x-intercepts before, so that was nice. And then finally, part F, also multiple parts of these problems, asks for the y-intercept. That's the easier one. So you're going to replace x with 0. What you're really going to do is simply go find f of 0. So we're going to plug in 0. So f of 0 would be 2 times that 0 squared minus 0 minus 1. Anything with the 0 is gone. We're going to end up with that -1. So the y-intercept is -1. So we know a lot about the picture. We just don't know what the picture is. So we can find the x-intercepts. We found a couple of other points. We know its domain. Okay, the one you're going to do is very similar. It's a rational function, but it works kind of the same way. So, any comments about that? Doing good? Okay. Okay. Example 4 I threw in because I think it's a really good example. What it's going to do is it gives us 5 pictures. I'm going to draw them kind of quickly on the board. The one picture looks like that. The next picture does this. The next picture does this. The next picture does this. And then the last picture does this. And then what they're going to do is give us a description and ask us to match the description to each one of the drawings. And they label these with Roman numerals. So here's 1, here's 2, here's 3, here's 4, and here's 5. So, okay, so I'm just going to read them and see if we can match them. The cost of building a house as a function of its square footage. So the cost of a house as a function of how big it is. Well, I don't know about you, but if I build a bigger house, it's going to cost me more money. So which one of these looks like a direct variation kind of question or relationship? It should be number 3, because we can see that if we put the square area on this side, that the cost over here is increasing. So this would be A. So this would be A. The next one says, the height of an egg dropped from a 300-foot building as a function of time. Well, if I'm dropping an egg off the top of the building, I know it's falling down. So time is going to be on my horizontal axis. The height is on the x-axis. And because of gravity, it speeds up as it falls down. So either 4 or 5 might fit. Let's leave that one alone and come back to it. Use a process of elimination. Part C says the height of a human as a function of time. Well, you grow up into a certain age, early 20s, and then you level off. So definitely number 1 for part C. The next one says the demand for Big Macs is a function of price. Ooh, this is a good one. So if a Big Mac was 10 bucks, would you still buy a Big Mac? I would not. Of course, my first job was at a McDonald's, so I probably would buy a Big Mac anyway. So, but this is a cost and a demand and supply kind of equation. So we can see that as the cost is increasing, so this is the cost, the demand for it is going to decrease. So this is D, which then backtracks and tell me that the egg dropping is this guy, which is C. And then the last one is the height of a child on a swing as a function of time. This is definitely swinging. So here's time, here's the height, and that would be party. So this is actually one of the problems out of your book that we didn't assign. It is number 44. If you go to the e-text and look at 44 and 43, I think it's worth looking at just because they're good problems. Okay, one more and we'll be done. You do have a problem similar to this last one on your homework. Throwing the eraser around. I will be sending out lecture notes for tomorrow also. We do a lot of pictures again. So if you could have those handy, it will help. This is example 5. Okay, we've got 2 functions this time. So one of them does this. This is what takes up so much time, is copying stuff onto the board. So it comes here and does this. And then it's got a nice gentle slope on this side. 3, 4, 5, 6, 7, 8. So we're crosses. And it does this. So, and that is our f function. So it tells me that this one is f of x. Okay, and then I have a second function that's a lot uglier looking. And there's no way I'm going to draw it very nicely. So it's not going to look as pretty as the one on the handout, that's for sure. So it's got a point over here, -1, 3. It goes up and does something like this. This is at 1, 4. It then continues to fall to 2, 2. And then 3, 1. So it curves down. Then it rises back up again. 2, 5, 4. And then it ends at 6, 5, 6, 5, 4, 5, 6, and 7, 5. So it becomes straight. So there's that. So it looks something like that. 6, 5, and 7, 5, 5, 4. Okay. So once we've got these two, and this is g of x, so g of x is in blue. What the question is, it's a lot easier to write the question out than it is to do the entire problem. What we're gonna do is a graphical addition, subtraction, multiplication, and division. So this springboards off of what we did yesterday. So part A is asking me what f plus g of 5 is. So we saw yesterday that this notation simply means that we can find f of 5, we can find g of 5, and then we can add them together. So f of 5, according to the picture, is right here. And it's a 0.5, 1. So f of 5 is equal to 1. G of 5 is sitting over here, and it's equal to 4. So again, I'm picking up this value and this value off the two pictures, and then I just add them together. So 1 plus 4 is equal to 5. It's in this section because you now know how to read a graph. Part B on that question is asking me for g minus f of 7. So again, what I need to do is find g of 7, and then I'm going to subtract off f of 7. So g of 7, that's the blue graph. G of 7 is equal to 5. F of 7 is sitting here. Here's 7, the coordinates. And these coordinates are actually marked on the picture, so it's easy to pull them off. F of 7 is equal to 3. So I took both of the y values, and then I'm going to subtract them, and end up with 2 is my final answer. Okay, does everybody see what we're doing? Again, if you have the nice picture, it's a lot easier to pull everything off of.
Is it determining the distance between the two?
This one would be, yes. So g minus f of 7 is literally telling me the difference between the two. This one over here is adding, so it's not. Distance is always a subtraction. So this is simply taking, and what this would be is like you have two different functions. One might be governing the cost of producing the tires, and one might be the cost of producing a different size tire, and you want to know what your overall cost function is. You would add those two costs together. So that's what they're kind of having us do. Part C is f times g of -1. So here we're going to multiply together. And I can't think of any reason why we would need to multiply in the immediate future, but you can multiply functions too. So we're going to find f of -1 and then multiply it by g of -1. So f of -1 is going to be over here. This was -1, +1. So that value is equal to 1. G of -1 is up there at 3. So again, they're giving me the x's. I find the corresponding y's and then do the arithmetic it says to do. And 1 times 3 is 3. And then finally, part D is asking for f divided by g of 6. So we're going to go find f of 6, and then we'll find g of 6, and then we'll divide them. Okay, f of 6, that's the black one. F of 6, according to the picture, is at 6, 2. So we'll pick up the 2 is our y coordinate. G of 6 is up there at 5. That's on the blue function. So we end up with 2 over 5, which I'm going to leave as 2/5 because it doesn't divide evenly. And I hate to go to decimals. You've had me before, you know I'm anti-decimal. So we'll just leave our answer as 2/5. So we can graphically add, subtract, multiply, or divide functions also from the pictures alone. So, okay, and that wraps up section 3.2. Both 3.1 and 3.2 are due tomorrow. And in case you didn't catch, I did go through, and from the people who sent me their scratch work, I went through and regraded and gave partial credit on those exams. I did type in some comments so you can go back into that exam and you should be able to look over and see if you missed something, what you did wrong. And that's now there. And I brought all the grades over into Blackboard from last week, so you can take a look in Blackboard and see what your course grade is sitting at right now. So any other comments or questions?
No, I'm good.
Okay, have a great day. Enjoy it.
Two.
Get it, son. Bye-bye.
Bye.